G'day, I'm Alister Christie from LearnDelphi.tv. A bit about me. I've been using Delphi since version 3. I'm an Embarcadero MVP, and you can find more about me and other great Delphi video tutorials at LearnDelphi.tv. This video is titled A Real-World Refactoring Example. I've used Delphi XE6 for this video, but many of the techniques discussed will be valid all the way back to Delphi 1. I think the automated refactorings were introduced in about Delphi 2006. Skill sprints are short one skill tutorial sessions, with the demo portion taking about 20 minutes, or in my case 24 minutes 56 seconds. So moving on, as we want plenty of time for the Q&A. What is refactoring? Basically it's changing code without changing its external behavior. There's some pretty heavy methodology to go along with how to make these changes, which I'm playing extremely loose with in this tutorial. And finally, now for the demo. As I've gone over time, let's get stuck right in. I have an application here called Property Analyzer. It's an investment property analysis tool, which I wrote about 10 years ago, and some of the code in it is quite hideous, which makes it an excellent example for finding some refactorings. So let's just run it. And what we're going to do is refactor some of the code related to the calculations that produce all these numbers. So what I'm going to do is press Alt print screen and go to GIMP and paste in a copy of our report, and we're going to be using this for testing so we can compare if the old report with new variations and verify that they are still the same. So if we have a look in the print method, we see there's this calculate future financials, and that's the bit of code we want to deal with. So I'll just control click into that. And if we pick something in here, such as this won't be subtle, so it'll be quite obvious the change, and run it again. Bring up our report, no big failures, but if I go Alt print screen and Control V, you may have seen the things change. We can toggle the visibility of the new layer and see that things are quite different. And even better, if I change this to difference, we can see the differences between the two images, and so it's an excellent way of detecting changes. So I'll just undo all that, come back and undo that change. So we're now going to extract all of this code into its very own unit. So we'll start by creating a new unit, and we'll call it calculate future financials, and we'll create a class. Now what we're going to be doing is a refactoring called extract method object. So we're going to take all of this code and extract it into its own class, and we're going to create a procedure called perform calculation. So what I'm going to do is just take all of this, of which there is lots and lots and lots. There's I think about 220 lines of code from memory, so I'm just scrolling to give you an idea of the task ahead. And let's paste that in like so. And we'll see that we've got lots and lots of errors we need to tidy up. Firstly, I can have a look at the client. You're going to see that with statements and all sorts of horrible things in here. I wrote this about 10 years ago, so my code is much better that I write today. But yeah, anyway, carrying on. So I'm going to use find. So it's in the refactoring menu. It's not really a refactoring, but it's quite handy. So find unit, which will tell us that we need to include, and I'm going to put in the interface, datasnap.dbclient. And there's also decode date, and I can use the shortcut key Control Shift A and DM data. Now another thing I'm going to do is take this procedure here, which is a nested procedure, which is sort of frowned upon these days. So I'm going to throw it out there and prefix it with the class name, and then press Ctrl-Shift-C to create the declaration in the private section. And I'll just undent that as well. These other red squigglies, these are form methods and variables and what have you. So with a lot of refactorings, you end up taking a couple of steps backwards to go forward, and that's what we're going to do by going use unit and unit 1, and we have, I'll just bookmark that, global variable F property analyzer, and I can throw that at the beginning of each of these problems. Oops. And almost done, and I think it's all of them, and I'll just verify that and see if we compile. Yes, we do, and we want to call our code in a new class, so we need to use the unit. And sure why that's not oh, it's probably private or something like that, but anyway, and let's go Ctrl-Shift-V. No, I won't. I'll right click and go refactor and go declare variable. Okay, and okay, that does indeed compile. So what we'll do now is we'll run it, and fingers crossed, go print, and we get our report, and I'll go Alt print screen, down to GIMP, paste it in as a new layer, and go difference, and we see it's completely black, so the two layers are identical. Our next step is to remove our dependency on our form. So we want to eliminate any sort of UI / business logic dependencies, and this is a rather nasty one at the moment. There's a number of ways we could do this. Probably one of the easy ones would be to add a whole bunch of properties to our calculate future financials class, such as capital gains, and then in here would say cff.capitalgains equals get capital gains. But I'm not going to do that. Instead, I'm going to add an interface. Now, one of the reasons for doing that is there are a couple of methods, get mortgage values, which we could probably shift into this class, but I'm instead going to extract an interface from F property analyzer. So let's do that now. So if we come up to the top of our class, what we want to do, and I have, as I've done this several times before, want to extract these methods, I think, into an interface. So I'm going to create a new unit. And rename it Property Analyzer Interface, because our form is called F Property Analyzer. And add a GUID in there as well. And basically, it's going to copy those and paste them in there. And up in our form, way up the top there, we're going to give it an iProperty Analyzer interface. So we can compile that, and of course we need to Control Shift. Okay, that's going to work. Interface. Okay, include that. Okay, now it's worth noting that with forms, and I think a lot of controls and components, they implement the add ref and the release ref in that they return -1, so that the reference counting doesn't actually have an effect. The sort of automated freeing of interfaces, which is what we want in this case, because we don't want our form to be freed. So that's quite convenient. So in our perform calculation, if I scroll up, we're going to add a new parameter. In fact, I think there's a refactoring for adding parameters, but let's add Property Analyzer Interface. In fact, let's might as well use the refactoring menu. Okay, change parameters. I'm going to add and eventually parameter name. I'm going to call F Property Analyzer the same as our form. And we'll actually pass it as const, as you should do with interfaces. And let's perform that refactoring. And I should also be able to remove unit 1. So let's compile that and see if I've okay, so we need to add private. And it's going to return years. Oops. Get mortgage values. Oh, okay. So yes, we needed a couple more, and I think we need the next one down too. So we'll throw those on our interface. Okay, our refactoring didn't quite work properly. And in fact, pass in self in case. Okay, so basically we've just created a new interface. We've implemented that interface on our form, and rather than using our form, we are passing it in, passing in an interface, and I'll rename that. So it's a rename refactoring, which is probably the most commonly used. That and extract method are the two that I use, which I haven't covered extract method yet, which we will shortly, if we've got time. And that does indeed compile. Let's run that. Print, go alt print screen, paste it in, go difference, and they're exactly the same again. Our next step is that our calculate future financials procedure, or TF property analyzer in general, has this dependency on calculate future financials, and thus a dependency on all this code. Now, dependencies, I like removing them where I can, and removing this one is quite straightforward. Basically, we're doing another extract interface refactoring. So we need a new interface, and so we'll do that in a new unit. And rename that calculate future financials interface. Okay, and that's going to have one method on it, which is perform calculation. And we want to include the unit with our property analyzer interface. And we can come up here and say this is now descending from I calculate future financials. Oops, Control Shift A. Okay, so there's another extract interface refactoring done, and come back here. We can say, oops, this is now an I future financials, and we don't need that. And I'm going to check that in the interface for now as well, rather than the implementation. Okay, so basically, so far we've eliminated a line of code by adding a whole heap around our interface. But what we can do is, rather than making that a local variable, I'm going to make it a public. Well, I could make it a property, but we'll just make it a field for now. And go to our main form. Let's go back here. Not main form, but our main unit. And inject that dependency. So if property analyzer, oops, that a little bit prematurely. That's correct. No parameters. Okay. And I can come up to our users, and we are no longer dependent on calculate future financials. So it's a pretty primitive form of dependency injection. Spring was much more sophisticated, but that's way more than we've got time to go into today. So just do Alt print screen, back to GIMP, Control V, and difference, and it's all black, so all good. We have pretty much run out of time, but I want to do one more refactoring, which is one that I use a lot, and that's extract method. And if we come down here and we have a quick look at some of this code, looking for something that's a reasonable candidate, let's look at this sort of while loop, and if we highlight that and go refactor extract method, we get a little preview. Now, I tend to go through code and sort of highlight bits and do sort of these trial refactorings to see what parameters and things end up being present, to see if it extracts nicely. This is not too bad. We've got two things. It's calculating t, whatever that happens to be, which looks like something to do with the depreciation value. So that's rate times original value. So it's divided by hundreds. That's some sort of percentage, I guess. That's the percentage. So yeah, so it'll be some sort of value, depreciated value, something like that. So total depreciated value might be a valid variable name for that, but not totally certain. But actually, t, if we have a look around, we see, okay, t is being set to 0 here, and likewise with our Chettl's value. So we'll do a little bit of reordering of statements. We see there's no dependencies on these there, and if we have a look, highlight t and scroll down, and we see it's being used here. And so that's average depreciation, which is being assigned, so that's new effectively, and Chettle value, and that's also not being used in the above code, so we can actually shift that as well. So I guess at some stage this big block of code was injected, but really we want these to be together. So we've now got a slightly larger block, and Control Shift M, and we'll see that we've got our Chettle value and average depreciation, and t is now a local variable. And t should probably be a type currency or something, but anyway, likewise the Chettle value, but double is good enough. So I'm going to go ahead with this refactoring, and it's good to call it the method, of course, by what it does. So it's calculating the Chettle value and average depreciation. So when I've got long method names like this, that tends to indicate that it's doing too much, but I had a bit of a look at this earlier, and I couldn't see a nice mechanism of breaking it up into calculate Chettle value and calculate average depreciation as separate processes or separate methods. So we'll apply that. We've now extracted that chunk of code into a single method, and if we have a look at that method, it's now performing our calculations. And if I go back and look in here, you'll also see, or perhaps not, that the variable t has been removed and is now made local. So the refactoring engine is pretty smart for extract method. I have seen it go terribly wrong on occasion. Typically, it'll have unnecessary parameters or remove parameters. Sort of the worst kind of thing I've seen. I've seen it crash in earlier versions of Delphi, but not XE6. And I haven't had any problems with it at all in XE6 as yet. So fingers crossed. And we should, of course, do our testing primitive as it is. And of course it is the same. We've covered a number of refactorings in rather a crude fashion. However, in so doing, we've managed to somewhat improve our code quality, although it's still pretty hideous. Normally you wouldn't do refactorings just for the sake of it. Instead you'll be trying to add some feature, but want that feature to fit cleanly in with existing code. Our first refactoring was extract method object, where we took a method and created a whole new class around it. We then extracted an interface from our form to remove the dependency on the form in our code, and we then repeated the process in reverse to remove the dependency of our new code from the form. We then used the extract method refactoring to pull out a bit of code, reducing the size of the perform calculation method. We also squeezed in a couple of renamed refactorings. Resources for general Delphi stuff. Watch more of my videos available on LearnDelphi.tv. I'd also like to highly recommend reading the refactoring book by Martin Fowler, and there are a couple of IDE plugins that you can take advantage of that add some additional refactorings. I'm particularly fond of the Model Maker Code Explorer, but I've also used Gustalia in the past.